Through this presentation, we are going to learn about the concept of limit of a function. In this video, we learn about the concept of limit. इस वीडियो के माध्यम से हमें लिमिट के बारे में जान पाएंगे. So, what is limit of a function? What do you mean? What do you mean by limit value of a function? लिमिट क्या है? एक फंक्शन का लिमिट वैल्यू क्या है? आइए लिमिट के बारे में जानने के लिए पहले एक फंक्शन y is equal to fx equal to 1 minus x लेते हैं. In order to know about the limit of a function, let us take a function y is equal to fx equal to 1 minus x. Now, we calculate the values of y for different values of x. अब हम y का values निकालेंगे for different values of x. If x is equal to 0, then y is equal to 1. That is, when x is equal to 0, then y is equal to 1 minus 0 is equal to 1. When x is equal to 1, then y becomes 0. When x is 2, then y is equal to 1 minus 1. When x is equal to 3, then y is equal to minus 2. When x is equal to 4, then y is equal to minus 3. When x is equal to minus 1, then y is equal to 2. When x is equal to minus 2, then y is equal to 3. When x is equal to minus 3, then y is equal to 4. When y is equal to minus 4, then when x is equal to minus 4, then y is equal to 5. Thus, we get the values of y for different values of x. हमको y का वैल्यू मिल गया है for different values of x. Now see, when the values of x approaches to 0 from positive side, then the values of y becomes 1. That is, when x tends to 0 from positive side, then y becomes 1. That is, y is equal to 1. देखो, जैसे जैसे x का वैल्यू पॉजिटिव डायरेक्शन से y तक आ रहा है, y का वैल्यू 1 हुआ है. So, when x tends to 0 from positive side, then y becomes 1. And this idea or this concept is called limit value of y when x tends to 0 from positive side is equal to 1. And this is called right hand limit. इसको कहते हैं right hand limit. Similarly, when the value of x approaches to 0 from left hand side or from negative side, that is x tends to 0 from negative side, then value of y becomes 1, that is y is equal to 1. So this is called the limit of y when x tends to 0 from negative side is equal to 1, or this is called left hand limit. Thus we get the idea of right hand limit and left hand limit. For the function y is equal to fx equal to 1 minus x, the limit of y x tends to 0 from negative side is equal to limit of y when x tends to 0 from positive side is equal to 1. That is when that is left hand limit is equal to right hand limit. So this concept is called the limit of y when x tends to 0 is equal to 1, or the limit of function fx when x tends to 0 is equal to 1. So that is called the limit value of y when x tends to 0 is 1, or limit value of the function fx when x tends to 0 is equal to 1. For any function y is equal to fx, if left hand limit is not equal to right hand limit, then the limit of the function y is equal to fx as x tends to 0 in this example does not exist. That means if left hand limit is not equal to right hand limit, then the function has not the limit value at the particular point. Here, since limit of y when x tends to 0 from negative side is not equal to limit of y when x tends to 0 from positive side, then the limit of the function y is equal to fx as x tends to 0 does not exist. Example 1. Test whether limit exists of the following function at x is equal to 0. The function is given fx is equal to 1 minus x when x less than is equal to 0, and fx is given as 2 plus x for x greater than 0. Solution. Left hand limit is, the left hand limit of this function is limit fx when x tends to 0 from negative side is equal to 1 minus 0 equal to 1, because the value of left hand limit of fx at x equal to 0 is dictated by the value of fx when x less than 0, which is indicated by the red underline function. The right hand limit is limit fx when x tends to 0 from positive side is equal to 2 plus 0 equal to 2, because the value of right hand limit of fx at x equal to 0 is dictated by the value of fx with x greater than 0, which is indicated by the function underlined by red line. Here, limit of fx when x tends to 0 from negative side is not equal to the limit of fx when x tends to 0 from positive side. That is, the left hand limit is not equal to right hand limit. So the limit of the function y is equal to fx as x tends to 0 does not exist, or limit of fx when x tends to 0 does not exist. Example 2. Find limit of the function x square minus 6x plus 9. Here, simply replacing the value of x, we get the limit value. So the solution is limit of x square minus 6x plus 9 when x tends to 1 is equal to 1 square minus 6 into 1 plus 9. Here simply we replace the value of x as 1. So that is equal to 1 minus 6 plus 9, and that is equal to 4. Here we get the limit value 4 for this problem or for this function. Example 2. Find limit x square minus 9 divided by x minus 3. Here this function has some prior algebraic simplification. So we have to simplify it. Without simplifying, without adopting the prior mathematical or algebraic simplification, if we put the limit value, then that will be the wrong, and in that case the limit value will be the 0, or it is not a limit value, just it is simplest replacement value. So we have to simplify at first. Now how to simplify it? Solution: limit x square minus 9 divided by x minus 3 when x tends to 0 is equal to, here we can write x square minus 9 as is equal to x square minus 3, and also that is equal to x plus 3 into x minus 3. So we write the limit x square minus 3 square divided by x minus 3 when x tends to 0, and that is equal to limit of x plus 3 into x minus 3 divided by x minus 3 when x tends to 0. Here the numerator x minus 3 is cancelled by the denominator x minus 3. Thus we get limit of x plus 3 when x tends to 0. Here we put the value of x as a 3, so we get 3 plus 3, so that is equal to 6. Now here we get the limit value for this function is equal to 6. Here the limit value is the 6 for this particular problem. Again, find limit of the function x square minus thrice x plus 2 divided by x square minus x minus 2 when x tends to 2. Here also we have prior mathematical or algebraic simplification. The solution is like this. Here the numerator x square minus thrice x minus 2 can be retained as x square minus twice x minus x plus 2, and the denominator x square minus x minus 2 can be retained as x square minus twice x plus x minus 2. Now taking the x common, we can write the numerator as x into x minus 2 minus 1 into x minus 2, and in denominator we get x into x minus 2 plus 1 into x minus 2. Now we take common x minus 2 into x, we take common x minus 2, and the numerator becomes x minus 2 into x minus 1, and the denominator becomes x minus 2 into x plus 1. The numerator x minus 2 is cancelled by the denominator x minus 2, and we get limit of the function x minus 1 divided by x plus 1 when x tends to 0. Here simply we put the value of x as a 2, so we get 2 minus 1 divided by 2 plus 2 plus 1, so that is equal to 1 by 3. So 1 by 3 is the limit value of this function when x tends to 2. Again, find limit of the function square root of x square plus 9 minus 3 divided by x square. See, in case of the limit value, if we have the square root in numerator or in denominator, then we have to adopt a special technique. Now let us see the technique. Solution: the limit value of x square square root x square plus 9 minus 3 by x square when x tends to 0 is equal to we get the term, we get by multiplying both the numerator and denominator by the reverse of numerator, that is square root x square plus 9 minus 3, that is square root of x square plus 9 plus 3, we get this. That is, in this particular case, we have to multiply the numerator and denominator by the reverse of the numerator. Here the numerator is square root of x square plus 9 minus 3. So its reverse is square root of x square plus 9 plus 3. Simply altering the sign of 3, we get the reverse. So that's why the limit of this function is equal to, we get square root x square plus 9 minus 3 into square root x square plus 9 plus 3 divided by x square into square root x square plus 9 plus 3, and that is equal to nothing but limit of square root x square plus 9 whole square minus 3 square divided by x square into square root x square plus 9 plus 3, and that is equal to limit x square plus 9 minus 9 divided by x square square root of x square plus 9 plus 3 when x tends to 0, because after squaring the square root we get, after squaring the square root of x square plus 9 we get x square plus 9, and after squaring the 3 we get 9. Thus we get, by cancelling the plus 9 with negative, we get x square in numerator, and in denominator we get x square into square root of x square plus 9 plus 3. The cancelling the x square of the numerator by the denominator x square, we get limit 1 divided by square root x square plus 9 plus 3. Now here we put the value of x as 0. So we get 1 divided by square root of 0 square plus 9 plus 3. So that is equal to 1 by square root of 9 plus 3, and that is equal to 1 by square root of 9 is 3. So 3 plus 3 we get 1 by 6. So this is the limit value of this particular problem, and this is the way how we can calculate the limit value of a function, and this is about the concept of limit, and this is about the procedure of calculation of limit value of the function. Thank you.